Hello everyone. Today in this video let us continue the second question from exercise 2.2 of chapter 2 polynomials. Okay. The second question is find a quadratic polynomial each with the given numbers as sum and product of its zeros respectively. So in each of the question you are given sum of the zeros and product of the zeros, and you need to find the quadratic polynomial satisfying this as the sum of the zeros and product of zeros. Okay. So if alpha and beta are the zeros of a polynomial, then the polynomial general form you can write it as x square minus alpha plus beta times x plus alpha times beta. So this is the general form of the quadratic polynomial where alpha and beta are the zeros of this polynomial. So every time sum of the zeros you can substitute here and product of the zeros you can substitute here and get the polynomial ready. Right? Let us start with the first question. Our first question is sum of the zeros is given as 1 by 4 and product of the zeros is given as minus 1. Let us substitute these values in the quadratic formula, quadratic polynomial. So x square minus 1 by 4x plus minus 1. Alpha into beta is minus 1. So let us simplify this and put it in the general form, because if we don't want a fraction form in the middle term, let us write everything multiplied by 4. Because to remove this 4, we are multiplying this whole quadratic polynomial with 4. So 4 into x square, 4x square, minus 4 into 1 by 4 gives you 1. So just x, plus into minus is minus, minus into 1 into 4 is minus 4. So this is the question number 1 answer, quadratic polynomial of the first question. So coming to the second one. So here the sum of the zeros is given square root of 2 and product of the zeros is given 1 by 3. Let us substitute these values in the equation, in the quadratic polynomial. X square minus alpha plus beta is square root of 2, square root of 2x plus alpha into beta is 1 by 3. Let us write here 1 by 3. So this is the polynomial. To remove this fraction form, let us put it into everything into, multiply everything into 3. So 3 into x square, 3x square, 3 into square root of 2 gives you minus square root 2, 3 square root of 2, 3 root 2 otherwise, plus 3 into 1 by 3 gives you 1. So this is the polynomial for the second question. Okay, coming to the third one. So 0 square root of 5 are the sum of the roots and product of the roots. So let us take third question. Alpha plus beta is given 0 and alpha times beta, product of the roots, is given square root of 5. Substitute these in the quadratic polynomial. We get x square minus alpha plus beta is 0, 0 into x plus alpha into beta, square root of 5. So which you can write as just 0 into x is 0. So we need not write that. Just you can write x square plus root 5 is the answer. That is for third question. Coming to fourth. So we have fourth one, sum of the roots is 1 and product of the roots is also 1. So alpha plus beta equal to 1, alpha into beta is also 1. Let us substitute in the quadratic polynomial. We will get x square minus alpha plus beta is 1, 1 into x plus alpha into beta, which is 1. So just you can write it as x square minus x plus 1. This is the answer for fourth one. Now coming to the fifth. Minus 1 by 4, 1 by 4. So fifth one, given fifth question, alpha plus beta is equal to minus 1 by 4 and alpha times beta, product of the zeros, given plus 1 by 4. Now substituting them into the polynomial, we get x square minus alpha plus beta, minus 1 by 4x plus alpha into beta, which is 1 by 4. So simplifying a little more, minus of minus, plus 1 by 4x plus 1 by 4. So to avoid the fractions in the middle, you can multiply throughout the polynomial by 4. We get 4 into x square, 4x square plus 4 into 1 by 4 x, which is just x. 4 into 1 by 4 gives you just 1. So this is the polynomial for the fifth question. Coming to sixth question. Given sum of the roots alpha plus beta is equal to 4 and product of the roots alpha times beta is given 1. So let us substitute these also in the polynomial. We get as x square minus alpha plus beta, which is 4x plus alpha times beta, which is 1. Just. So this is already in standard form. So this is the answer for the sixth question.